It's just the way that the way it's doing the calculations is always working from the left side up on a 0 to whatever, okay? You don't do a range. That just doesn't work that way.
So for at least 10, you do
Oh, yeah,
one
because
minus
we had
at
to plug
most
it
10.
in. We had to put the left bound.
Yeah.
And
It's
then
weird.
whatever.
That was only normal. There was no left bounds ever with binomial. Okay? Because there's no range. It's specific. That's discrete.
So for at least 10, it's 1 minus at most 10.
It's 1 minus less than 10.
Oh, because, yeah, these things match.
Okay? So where in here are some binomial questions? I know I saw a couple. Let me see if there were. I thought. If not, we'll make some up. I know there's normal questions in here.
I can make some random stuff from the test.
That test is really easy. The test is actually really easy.
What
Yeah,
is?
if we had this review,
We
it'd
had
be
a
easier.
probability test that was
Oh,
that's
yeah.
due on Monday. It's
Who's
not
got a
that
book? Give me a book. Abby's got one out right there. Or Wendy's got one out, whatever.
I think I don't know what my book is.
You're gonna be paying for it.
How much is it?
Like $50 or something.
Why can't
Are
we
you getting
afford
more
more
next year?
books if we can afford it?
Where do all the old IB books go?
What do you mean old IB books?
Like, when you buy new IB books.
We don't. We haven't bought new IB books in pretty much anything in forever.
The bios are kind of new.
But they're not IB books.
The AP books.
We never had one before.
Those are IB books, not bios.
Okay.
The orange ones?
Yeah.
The orange one, that's the first IB bio book we've ever had. We've always just used those other green books that they used in AP.
Oh, that's gotta suck. Those suck.
So like, there must be like an IB book debt.
Yeah, third world countries.
Like, no one else.
What is wrong with you?
That's probably true.
Okay. All right, so we'll look at one of these questions real quick. All right. A student, we're looking at number 6 here. A student guesses true false answers at random for a test of 20 questions. Find the probability that this student is correct in all 20 questions. Okay. What's the probability of success here? 1/2.
No.
Because they're guessing.
Right.
Okay. So we're looking at 20. So what you would do here,
Binomial
2.5 to the 20.
PDF, right?
Yeah.
What?
0.5 to the 20.
No.
The chances are still high.
Can we
Let's
just
just
do
say
it the
it's-
right way?
Now I know why guessing never works on tests.
That'd be impossible.
Yeah.
There's a lot of zeros.
so there you go.
Yeah, we got to see it.
Right. But you're not going to get the same answer on the next one. B, exactly half the questions. Okay.
Yeah,
So
what
again-
did you put in for the
20, because it's exactly how
Because it's 20, it cut it off, but it's exactly 20. Yeah. Again, if you think about this, what binomial, the reason it's called binomial is because think about binomial expansion you did back before. Okay? What we're really saying here is instead of, I mean, it's easy to do on what you just, on this one, what Dimitri said, is because basically you're saying P plus Q to the 20th, right? And you're figuring out which one along the way. When you spread this out, you have when this is P to the 20th plus that coefficient times P to the 19th times Q to the 1st, right? So it's taking care of the fact that you have, especially now think about when this is 100 or 1,000 like it just was, or different things, okay? Is it's all the different ways, all the combinations of doing that, where you could have, if I have 20 successes, I don't know if those 20 are going to be the first 20 or the last 20 or mixed throughout or whatever. That's what binomial is doing. It comes back to this distribution thing. All right, not that you really care where it comes from, you just want to get the answer. Right, Wendy?
No.
Okay. B, exactly half the questions. So if I'm talking about exactly half the questions, yeah, then you're going to say binomial PDF. I'm using this one, I'm using that one.
Something's wrong.
you're saying you're doing 20 questions still. What's the probability of success is a half, and that you get 10 of them right.
Should be a half.
0.176.
It's not a half because there's so many different combinations of the other ones too. Of getting 1 right, 2 right, 3 right, 4 right, 5 right.
Gotcha. But that's the most probable
Yeah.
out of all.
If you do this, and leave this blank, it'll give you all of them. Okay? So that's that you get none of them right, and then this number is if you get 1 of them right, and then 2 of them right, and then 3 of them right, and then 4 of them right.
But that's exactly 4 or 5.
Exactly
Okay.
5 right, exactly 6 right, exactly 7 right. And so what we're going to see here is that that's exactly 8 right, that's exactly 9 right, exactly 10 right, and now it's going to just mirror itself down the other side.
If I add all
It's
those,
symmetrical.
that should be 100.
Yep. If we do CDF, if we do the binomial CDF, I don't care what this is, if these two numbers match, what are you always going to get as an answer? 1, because it's the cumulative up to 20, you're going to get 1. Because you're adding up all the outcomes at that point. Okay?
But you use CDF for like part C because it's not an exact.
Yeah, less than half the questions. So you're going to do CDF up to 9. Because less than half the questions would be that you get 9 or less correct. At least 15 questions.
So 15.
You're going to do 1 minus everything up to 14.
Would it be 15 because it's at least?
If I get at least 15, is 15 what I want? Yes.
Can you show
So what's the opposite of what I
15
want?
has to be included.
can you
So what
show
I would
that?
do here is at least 15 is going to be 1 minus the binomial CDF for 20 all the way up to 14. Because what's the opposite of at least 15?
No more
At
than
most
1.
14, right? Or less than 15, right? So there's my answer. Probably that I get at least 15 right.
So if it was at least 20, then at least 19 would plug it into 18.
For percentages, do we only round to 2 significantly low?
Always 3 digits. I would never do a percentage. I would answer this as 0.0207. Just leave it as decimals. You can do percentages. There's nothing wrong with doing percentages. Personally, I would never do percentages because I don't want to make a decimal error. And you don't have to, so why take that extra step and convert it?
I do that
Fractions.
today.
What?
I did that today. Oh
Doesn't
man.
even do it.
Nope.
No, there's no way.
Okay, so that's binomial a little bit, and you can look back at that, and if you find some questions in review, or you find something you want to look at, we can. Normal. Normal is now with a range of data, okay? So continuous data. And normal distributions is all based on this normal curve. Okay, we've all seen a bell curve before, right? If it's a perfectly symmetrical curve, then right here in the middle, what?
Then
That was
should cross.
definitely a straight line.
It is, what are you talking about? That's redundancy. Every line is straight,
Oh.
right?
Yay.
Well, then that only made more sense then.
Exactly.
Are you really sunburned or are you just turning around?
There we go. The mean in a normal distribution, the mean and the median are the same, meaning that I have a symmetrical curve.
Is there a mode?
And
It's
The-
a continuous distribution, isn't
So
it?
there's no
there's no
So
mode.
in a normal
In a normal distribution, the mean and the median match, and they happen at that, highest point. Okay, standard deviation tells us how spread out the data is, right? It's a, what do they call it? What's the word for that? It's, I don't remember. Standard deviation of mean, there's some word for, I mean, standard deviation of variance, if we're talking about how spread out that is. Whatever. The inflection point right here, where the concavity changes, all right, that's plus and minus 1 standard deviation. That's how I draw the little sigma thing.
Terrible at it.
I think I'm rather good.
Oh, that was 6.
No, it's the little sigma thing. Is that
It
better?
goes out right to the side.
Yeah,
Yeah,
it's
I
like a
can't just-
straight.
I know. There you go. Whatever. So, all we really need to know is that you always are doing across an interval. Sometimes that interval has an endpoint that is infinite, though, which means it's not really an endpoint. It's just it's all to the one side or the other side, right? So there's a trick to do that with the calculator. You may already know that, but I'll show you again. What did you guys do?
The catalog.
What?
And you put the.
What did you guys do for the endpoint if it was like greater than 750?
Nine.
We did 9E99.
What?
9E99.
Yeah.
Or
Or you can
negative.
just do E99 is fine too. It's all. That's
Yeah,
what
so-
I do. Just
I tried doing
E99.
E99 and it wouldn't work.
What?
I tried doing E99 and it
It's
wouldn't
like
work.
the test.
Well, then there was like another problem where
You haven't
Like,
done it yet.
Yeah.
in the book
And do
on
the
one
test,
page.
yeah.
I already turned my in. How can
Okay.
that start?
All right. So
I started
Sunday.
let's talk about how we would do this. The whole idea here is that you're talking about to do a normal problem, it has to tell you it's normal, and you have to be given the mean and the standard deviation, or you have to be given enough data values to work backwards to get mean and standard deviation using inverse normal and Z-scores. Okay? But normal problem, a basic problem is going to look like this. You know, you have a normal distribution, the mean is 700, the standard deviation is 15. What's the probability that X is greater than 730? You do not need to memorize those standard deviation charts on what percentage is more than 2 or less than 2 or more than 1 or less than 1. For the exam, you don't need to know that. I know you've seen that, you've looked at it, you don't have to memorize it. Rule of thumb is that plus or minus 2 standard deviations is usually, I'm sorry, 1 standard deviation plus or minus is about 2/3, 2 standard deviations is about 95%, and 3 is 99. Okay, but you don't have to memorize it. So how would I do this with the calculator now? I'm going to go to normal distributions in the normal distribution menu. For normal distributions, do you ever use number 1?
Probably.
Yeah, so-
Otherwise it wouldn't be there. Yeah.
What?
Occasionally you might use
Yes,
it.
right? Use it for the test.
Wait, aren't we finding an exact value, so you would use it?
Rephrase that. Remember.
Why would it
Do you
be
ever
there?
use number 2? Put it that way. Do we ever use cumulative?
Not
No.
really.
What did you just say, if it's over 30%, or 730,
No,
right?
that's inverse.
Would that be, usually?
Yeah, that would be inverse normal.
Okay, I'm sorry. Back up. Do you ever use normal PDF? No. Never, ever, ever. Because the backstory to this is that when you're doing a normal distribution calculation, you're actually doing integration. We're not, because we're using the calculator, but you're actually doing integration. It's the area under the curve, right? Okay, you're actually finding how much area is under that curve. If I integrate from one end to the other end, I'm going to get 1, because it's the total probability, right? Now, go back to calculus, integration. Can I integrate from one point to the same point?
No.
Is there an area under the curve? No. So can I know the exact probability at any one point along here? No. I can only know the probability between intervals. So I only use CDF. Never, ever, ever use normal PDF. Only CDF. Okay? So in this instance, I'm going to do between 730.
Then what does PDF give you?
It gives you an approximation. It's actually measuring the height of the curve at that point. But in reality, that has no true meaning. It's just a calculator approximation. Okay? And you're never going to need it for your test. So 730. And then here my upper bound is E to the 99, which is Google. right?
Pretty big.
Okay. And then what's my mean?
So, oh,
And what's my standard deviation?
15.
And so my answer is 0.0228. Right?
2% that is passed.
It's a lot easier than I wish. A lot
Now,
easier.
here's another way to do it. Okay? If you're a visual person, get the same answer a different way. All right? You can... No, we won't do that. Never mind. This is good. Okay, the other way is not worth going through right now. All right. Same basic setup. What's the probability that it's between 700, first of all, you never use equal either because you can't equal, and 725? Can we do that? Okay. All you're really changing here, if you just wanted to repaste what you just had in there, is you're just changing your upper and lower bounds now to 700 to what did I say, 745? 725. Your mean standard deviation are the same, so now my answer is 0.452 between 700 and 725. Right? You see what I'm saying here? That's how you do normal distribution. Okay?
So no distribution always has 4 values.
Mm-hmm. Lower, upper, mean, standard deviation. Now, what if I said, same setup, same mean, same standard deviation. What if I said 60% is above what number? 60% of the data fall above what number?
That's when you do the inverse, right?
Yes, you do inverse. Okay? Big thing I didn't say. Never, ever, ever on your test paper write out what you have here. Right? See what I'm saying? You don't write down 700, comma, 725, comma, 700, comma, 50. That's calculator speed. Don't write that down on your test paper. All right? This is enough. That's all you have to do. So I'm not going to write down INVNORM. All right? I'm going to say if I want to inverse normal, that's fine if you do that for the test, but that's not what you're going to write down on your,
Oh, man.
okay? I can write down inverse normal, okay? Or I can say the probability that X is greater than Z equals point what? 4, because if it's 60% is above what number? Wait, no.
Yeah,
0.6.
I'm sorry, I wouldn't mean 0.6 at that point. I'm actually going to use 0.4 and then inverse normal though. Okay, because it only measures from the left. Then I would say Z equals, and all I'm going to say is inverse normal. Sorry that I'm having to repeat or go back what I'm saying here. It's just been a while for me too. Inverse normal, 0.4. My mean is 700. My standard deviation is 15. So what I'm saying here is 40% lies below what, which would mean 60% lies above what, is what this is going to give me the answer. And it's 696. Okay? Quick rule of thumb. Understand what's going on here. If I said 50% lies below what number, do you need to pick up your calculator? No. 50% lies below what number?
700.
700.
Well, 50, I was thinking.
You're thinking standard, but we're not doing standard. 700. How do I know that? Because that's the mean. And the mean and the median are the same thing in a normal distribution. So 50% always lie below the mean. 50% lies above the mean. So if I tell you that 60% lies above what number, then that number has to be less than the mean. Because there's only 50% above the mean. And so if I need 60%, I got to be somewhere else over here, right? I need more of the chunk. Okay? Another way to show work on this to get some good points sometimes is to sketch the graph and shade, you know, kind of draw. If I'm looking for 60%, it's got to be somewhere over here. All right? It's got to be somewhere further beyond the mean to get 60% above it. Okay? So it has a little bit of number sense there. All right, let's look at some of these questions in here, and then I'll point out a couple other things.
What if someone says like, this number, here's the mean, and this is 3 standard deviations away, what is the number? What do you, how do you use that?
You use a Z.
You have to know. Well,
That's not Z.
let me answer our question first.
Yours.
It always goes from the left.
Right.
Inverse normal always goes from the left.
Okay.
Repeat, Dimitri.
Say, 700 is the mean, what number is 5 standard deviations away?
We need to know the standard deviation.
Well, if the standard deviation is
5 times 15.
Then 5 times 15 is 75, so it's 775.
okay, that's easy.
Yeah.
The Z, it's
I didn't know that.
literally the Z-score.
I don't know.
What have
That-
you been
yeah.
doing in biology?
What?
Remember,
I always-
all a z-score is how many standard deviations away it is.
Oh,
That's what z is. That's what z is.
okay.
Because it's z is simply x minus mu over sigma, right? So it's just subtracting the mean and dividing by how many standard deviations. How many standard deviations? The whole reason we even have a z. Next year IB exam, okay? The whole part here to z in here it disappears because the tables at the back of this also disappear. All right? The only reason we have z-scores is because of tables. Because before we had a calculator that could do everything we're doing now, I needed a way to do every problem no matter what the mean or the standard deviation is. So that's where the standard normal comes from. Standard normal says I can take a mean and I can take any mean and any standard deviation and scale it to fit on top of the standard normal, which is a mean of 0 and a standard deviation of 1. Right? And so I do that z-score thing is just scaling it down to how many standard deviations it is away. All right, I know there was lots of normal stuff in here, so we can start looking at it. Okay, on the page that looks like it says it says page 13 at the top. It says number 16 is the question. It gives you a normal curve, right? What time is it? 4:15. All right. We'll stay till 4:30 if that's okay with you guys, because I want to finish through these. Okay. The diagram shows the normal curve for a variable x. The mean of x is 23.4. The standard deviation is 1.75. Find the area of the region under the curve for which x is greater than 26.2 shaded in the diagram. So again, I'm going to go straight to my calculator. I know it's normal. It's only ever normal CDF. What's my lower bound here?
Negative 99.
26.2.
No, 26.
26.2. What's my upper bound?
99.
E to 99. It's 10 to the 99th power. Okay? What's my mean?
23.4.
What's my standard deviation? 1.75. So find what's the probability that it's greater than 26.2? Why did I put 26.5?
Close enough.
Don't look at mine, because I messed up. Okay, 0.0548. Right? Got it? Okay. All right. Let's see. Next page.
Oh, this was on a test.
The one that's due Monday.
Yeah, we tend to know.
You can do it.
Well, I won't do
It's
it.
really easy. Just plug it into the Z formula and
It's
solve
just
for
the
your
Z formula.
and you solve for your unknown
I
variable.
think everyone here has done the test.
Except for you.
You just said you
What's the
did
trick?
that. Yeah.
Next Tuesday.
I'll even tell her we did it today. I don't care. It's worth
You haven't
learning.
seen it?
I haven't looked at it.
What's the trick here?
Yeah.
Well, it's plus and positive and negative, right?
What's the trick on this one right now?
Which number?
What, which?
The
13.
variance of 100.
15.
Z-score.
variance
That's
of
the
100.
trick to this problem.
Okay, for 10 square.
So if you just 10,
Because if the
right?
variance is 100, what's the standard deviation?
10.
10. Okay? So now it's just 10 times this, all right, which is 11.2 added to that and subtracted from that. So it's 111.2, right? Or, yeah, and 88.8, whatever.
I just went through that.
Why do we,
It's like, okay, I can say that now.
why do they even have a variance if it's just a square root?
Too tricky.
It's trickier.
I don't know, a statistician probably uses variance even more than standard deviation sometimes, I think, I don't know. 23 here, the height of trees in a forest are normally distributed with mean height 17 meters. We're on the next page. Just flip over to the next page. You got it? Find the probability that the tree selected has a height less than 24 meters. Okay, the probability that the selected tree has a height greater than 24 meters is 0.06, so find the probability that it's less than 24 meters.
So it's
0.94, it's just complement, 1 minus 0.06. B, the probability that the tree has a height less than D meters is 0.06. Find the value of D. Again, this is a non-calculator question, guys.
Yeah.
It's 10. Why?
24 minus
Symmetry,
17.
Because it's symmetry. Okay? If I have a curve and I know 17 is the mean and 24 over here, there's 0.06 greater than 24, then over here where there's 0.06 less than a number has to be the same distance from the mean that 24 was. So if this is 7 away, this has to be 7 away in the other direction. That's how I know it's 10, knowing the symmetry. C, a woodcutter randomly selects 200 trees. Find the expected number of trees whose height lies between 17 meters and 24 meters.
14.
0.44.
Yeah.
Where are you getting 0.44 from?
You take the 0.06, or 1 minus 0.06 is the other 2.
Okay, well there's 50, I look at it this way, there's 50% greater than 17, right?
It's not 0.06.
There's 50% greater than 17, there's 0.06 that are greater than 24, right? That means there's 0.44 right here. This right here is 0.44 between 17 and 24, so that number times 200 is 88. That's a non-calculator normal distribution. You're using symmetry. They had to give you an area there to have you be able to work around everything else. Okay, the type of problem that's not on here anywhere, what I consider the only difficult normal problems are where they tell you, and again, this may not even work out good, but something like this. We know it's normally distributed, and we say the probability that X is greater than 48 is 0.12. The probability that X is less than 33 is 0.08. Find the mean and standard deviation.
You get a calculator?
Yeah.
That's fun.
We just did this in class.
Yeah, we did.
Like,
Was it like 40-ish?
That was so
equally
awesome.
space them apart.
Okay.
Just estimate.
Find the middle.
No. What do you not know?
Your standard deviation.
Two things. If you ever don't know two things, what should you think?
What do you-
Inverse normal.
Any problem, any math class, any math topic
System of
ever,
equations?
system of
Yeah, we
equations.
did that today.
Okay? System of equations. So what you're going to do here is you're going to do inverse normal of 0.08, and you're going to do inverse normal of 0.88. Why 0.88?
That's a 1 minus.
It's 1 minus point, because there's 12% to the right. You got to do the 0.88. And this is going to give you 2 Z-scores. Okay? Got it? So what's the inverse normal from 0.08? Because if you don't tell it a mean and standard deviation, then it just does the standard. You guys know that, right?
Why did you use 0.88
Now we do.
Well, now you do. Because I know that there is 0.08 over here to the left of 33, right? And I know that over here at 48, there is 0.12 to the right.
So you can just assume.
But I have to do the opposite. Inverse normal only works from the left.
Right.
So inverse normal, to deal with the 48, I have to deal with 88%. 88% is less than 48 is what this is really telling me. Okay? So I do inverse normal with 0.08. See, anytime you just pull up inverse normal, what's already filled in here?
0.
0 and 1, your standard, right? Until you change it? Okay. So basically what it's telling me is at negative 1 point, this is why I told you we're not going to work this all the way through because I made stuff up that's going to be ugly to work with. But this is this many standard deviations away. And now what this is going to tell me is this answer. And yeah, I'm using an extra digit just because it'll help keep accuracy.
That's
Okay.
how many, like 33 and 48 are away?
Yeah. 48 is this many standard deviations away from the mean.
Okay.
33 is this many standard deviations away from the mean. Now what I'm going to do is use this formula, right, to find mean and standard deviation. Because what I can do is I can say negative 1.45 equals 33 minus the mean over standard deviation. And I can say 1.175 equals 48 minus the mean over standard deviation. And now I have a system. And now I can use substitution or whatever, or elimination. I can multiply and whatever. I can solve that system now. Right? I can solve by graphing. I can do a lot of different things. Depends on how I want to do it. Okay?